With all that you've learned so far, we're now ready to move away from the fundamentals and more into advanced tools and data types. So we'll talk about NumPy and Pandas this week. Those are two Python packages that provide you with new data types that are more complex than what we've dealt with so far, and they implement a number of functions around those data types that fall in the category of advanced tools that let you do more complex things through simple function calls. A key concept in programming and automation is something we should review here, which is use existing tools. There's no need to reinvent the wheel, especially not in your position where you care about the science and the insights that you can gain through sophisticated data analysis, rather than the implementation of fundamental algorithms, which falls more into the computer science realm. So we want to use existing tools, NumPy and Pandas and other libraries. Later on, PyGMT, for instance, are tools that exist, that have been well tested and utilized in a broad range of applications, can be considered stable, and so provide you with functionality that is readily available without you having to go through the entire software development process that we kind of covered in the fundamentals. So you can limit your exposure to bugs or to problems of computational efficiency. Advanced data types are more complex than the basic data types you've dealt with so far. You've encountered integers, Boolean, float. You've seen lists or arrays in both Shell and Python, and you've encountered dictionaries in Python. These data types are more complex than a simple integer, which contains a value somewhere in memory, contains a sequence of values that in some instances can also be of varying basic types. So you can have arrays that contain both integers, floats, and strings, etc. For your science, though, most of your data is in some form of a table where you have some measurement values that are related to either moments in time. So at a certain time, you record a value at a sensor that lives someplace, and then maybe you record new values every 30 seconds or every hour, every day, right? But there's a relationship between a column that is time and a column that is the values. Another relationship could be spatial locations. You could have sensors that are distributed in some area that record some data at the same moment in time, and you just want to look at that one snapshot. The point here is there's a relationship between some variable depending on space or time. Images also fall in this category. They are two-dimensional observations of some values, say elevation, for instance, or elevation change at some point in time. And you can create similar time series with images, and then all of a sudden, instead of having a two-dimensional table, you have a three-dimensional cube with values that are organized in a 2D table along latitude and longitude, and then they have a timestamp associated with them. And as things change over time, you build up a cube of data. There are some advanced Python data types or tools that provide efficient storage and operations on such data. For instance, the NumPy array data type, or the Pandas series, and Pandas data frame. These are the tools that we want to explore this week so that you can focus on gaining insights from your data rather than having to work on the implementation of how you can gain these insights.